today's lecture, we'll be looking at the properties of matter. But then, we can't actually go into the properties of matter without knowing exactly what matter is. So, what is matter? Before we could define matter, I would like us to know the importance of why we need to know what matter is and how it behaves. In chemistry, there are a lot of laws, principles, a lot of facts that have been stated by chemists and scientists. How did they come about all these facts and principles? It wasn't actually something that was made out of assumption, or probably someone just woke up in the morning and was like, this is this, or A is equals to B. No. Every law and principle that's stated, or fact that was stated in chemistry, is actually gotten from a series of reaction and interactions from matter. Now, our environment consists basically of matter. Everything, including the food we eat, the air we breathe, the detergents we use at home, the furnitures we have in our houses, they're all products of matter. So, why do we need to understand what matter is? Because you need to understand your everyday experiences and the things that you actually do in your everyday life. We need to understand the processes. You need to know that as an individual, having an idea of your existence and why you behave the way you do is very important. Remember, Plato said an unexamined life is not worth living. So definitely, you need to examine to know exactly how these processes come to pass. That brings us to matter. So what is matter? Matter is basically anything that has mass and can occupy space. What do I mean by mass? Okay, now, mass is the quantity of material contained in a particular object or a substance. Yes, anything at all mentioned, pencils, biros, furnitures, they all constitute of what? Matter. So we could say that in our environment, living things and both non-living things, whether from natural sources or artificial sources, are composed of matter. That being said, how can I know that this is matter? Or how can I measure matter? Remember, I said matter is anything that has what? Mass and can occupy space. Matter is clearly defined or described in two terms. One which is mass and the other which is energy. Most times in our everyday life, we hardly say, what is the mass of this salt? We would likely say, what is the weight of this salt? So most people use weight other than mass. Although these two terms can be used interchangeably, they are not the same. That brings us to the concept of weight. Weight is simply the force acting upon the mass of a body. Yes. Now, one mass is actually constant. That is, if you have a bag of rice, let's say a 5 kg bag of rice, measured in Rivers State, that same bag of rice would have the same measurement somewhere in Kano State. So I could say, invariably, a 5 kg bag of rice is same here and it's same elsewhere. That's the property of mass, for it being constant. Then what about weight? Now, one mass is constant, weight varies. Remember I said weight is the force acting upon the mass. So it means whatever force you use determines the weight of the substance. Let's take for instance a structure. We have the beam balance. The beam balance is used to measure mass. Let's take a bag of rice as an example. So per se we want to measure the bag of rice. That's the mass of the rice. We place it on the beam balance to get the measurements. If this bag of rice weighs 50 kg here on Earth, in the moon it's going to have a different weight. Why? The force of attraction on the Earth is different from that in the moon. Yes. So what do we understand by this force? What's this force? This force is a gravitational force. Now, gravitational force is that force that acts downwards. Remember or recall that in physics we talked about a free-falling body. Have you tried jumping up? Of course, when you jump up, you definitely come down. What brings you down? That force that propels or the force that drags you down towards the earth is what we call the gravitational force. So, the gravitational force on earth is higher than that in moon. To an extent, you have an approximate value for G, that's gravitational force, to be 10. I said approximated, right? The actual value is 9.8 meter per second square, but then approximated to 10 meter per second square. On the other hand, the moon has a gravitational force of approximately 1.6 meter per second square. So the weight of a body on Earth will be greater than that in moon. Why? because the gravitational force differs. That in the moon is actually lesser, while that on Earth is actually greater. Remember I said that although mass and weight are used interchangeably, they differ from each other. Yes, we use weight more in our everyday life. We use weight more when we make sentences like, what's the weight of this? But that is not actually right. The question is supposed to be, what's the mass? Right? Okay, so let's look at the differences between mass and weight. Recall that, first, mass is the quantity of particle or matter in a substance. Weight, on the other hand, is the force of gravity acting on the mass. While mass is constant, weight varies by the distance from the surface of the Earth. Mass is a scalar quantity. Why? Because it has magnitude. That is, it has a value. While weight is a vector quantity. Why? It has a magnitude as well as a direction. So every vector has a value and also moves in the direction of the force. Another difference between a mass and a weight is that while mass is constant and does not depend on force, weight actually depends on force. So that having discussed about mass and weight, having a basic understanding of what matter is, we could now delve into the properties of matter. Now, properties of matter. How does matter exist? Properties are simply features or characteristics that we could use to describe a particular substance or an object. But then we need to understand that there are some states in which we see matter. Recall I said almost everything in our environment consists of matter, but then they exist in different forms. We have some in a fixed or rigid form, we have some in a free flow form, and then we have some that they want to either show themselves or exhibit a kind of randomness. I don't know if this strikes something familiar to you. Let's take, for instance, a cup of water. Now, if you pour the cup of water, you see that the liquid actually flows. Now, liquid, right? So, liquid is actually a state of matter. There are basically three states of matter. We have the solid, we have the liquid, and we have the gases. While the solid is that form of matter that has a rigid form, the liquid is that form of matter that flows, while the gas is that form of matter that actually diffuse. I believe you must have heard of that term before now. Let's take, for instance, the gas cylinder we have in our house. Have you ever experienced trying to turn on the gas cylinder and then there's a force? It's as though there's a force coming up from the cylinder. Yeah, you get that right. That's actually the process of diffusion, because these gases are always in random motion. So they want to exert pressure. They are looking for every little space to move out. Okay, let's look at the differences between these three states of matter. Now, while the solid, like we said, the solid has a rigid form. The liquid has a form not rigid actually, but it has a form that gives it the ability to flow. On the other hand, the gaseous states, they have a form that allows them diffuse. The solid cannot diffuse. You know, when you place a piece of stone at a point, it remains in that point, it doesn't move. But then, have you tried pouring water on the floor? You see that something actually happens. It spreads wild to different spaces, any space it could actually find. So now, a solid has a fixed shape, a liquid flows, a gas diffuses. Do you wonder how solid or the matter in solid is actually joined? How? Recall that I said that matter is made up of basic fundamental particles. These basic fundamental particles are atoms, molecules, and ions. Of course, this topic will be treated later in the course of our study. But then, like we said, they're made up of what? Atoms, molecules, and particles. The particles of a solid are closely packed. They are closely packed, so they make up a mass of the substance. While the particles of a liquid, they are loosely packed. That gives them the ability to flow. The particles of a gas are extremely sparsely packed, so they are always in motion. If you just touch probably a cylinder, you realize that even without touching, the particles of the gas are always in a process called diffusion. So now, another difference is that while these solids have strong intermolecular forces of attraction, remember we said they are closely packed. What makes them closely packed? There's actually a force binding them together. So these forces are called forces of intermolecular forces of attraction. So while the solid have higher intermolecular forces of attraction, the liquid have medium or moderate intermolecular forces of attraction. The gaseous states have the lowest what forces of attraction. Now, since they have understood why they are closely packed and the force of attraction between these different states, we'll look at another difference which can be drawn from their nature as well. Now, the solid is not a free-flowing substance, right? The liquid is a free-flowing substance, and the gaseous state is actually a freer flowing substance. The solid are actually moving in a regular motion, while the liquid move in a random motion, and then the gaseous state move in a more random motion. That being said, we can clearly state the differences between the three physical states of matter, which are the solid, the liquid, and the gases. Having understood, we look at the properties of matter. Remember, the essence of this study is to understand basically the things that happen around us. Simply, let's put it that chemistry is the study of matter, its properties, its nature, transformations and reactions it undergo. So whatever form or whatever reaction or process matter undergoes, chemistry actually deals with that study. So we'll look at the properties of matter. Now, what do you understand by properties? Simple. How can you identify a female? Okay, I have long hairs, I have certain features or characteristics that when you see, you could say this sex is actually a female. Same goes to the properties or how to identify matter. There are certain features or characteristics that matter has that we could be able to describe or say that this is matter. What are those properties? First, we have the chemical properties, and then we have the physical properties. I'll take the physical properties. Physical properties are those features or characteristics that you can see or you can identify without a change in the identity of the particle. That's without altering the chemical composition of that substance. You could tell that this is a substance because it has this feature. We could also say that physical properties are accompanied by what? Physical change. Example, we have melting, we have freezing, we have condensation, we have some of the separation techniques like crystallization, centrifugation, distillation, fractional distillation, and then we have magnetization. Let's take, for instance, melting. If you have a block of ice and this block of ice melts down into what? Water. Further boiling of water will take us to a form of matter called gas, preferably steam. That steam is actually a gas. So you see that ice contains what? Water, right? But it's the solid form of water. Water is simply made of hydrogen and what? Oxygen. So ice contains water. Water in the liquid form is still water, and then steam is a gaseous state of what? Water. You can actually observe that it has the same chemical composition throughout the three states of matter. So melting is actually a physical property of a particular matter. Same as freezing, same as boiling, same as condensation, same as any other process or change that you can see without a change in the chemical composition of that particular substance. That being said, we'll look at the chemical properties of matter. Now, chemical properties of matter. These are features or characteristics that can be identified when the chemical composition of a substance or an object has been altered or changed. That makes me inquisitive. How did you know that HCl, that is hydrogen chloride, is an acid? Or how do we know that it is corrosive? Don't worry, you get to know by taking a bottle of HCl and then try pouring it on your skin or try pouring it on your furniture. Of course, the furniture will wear out and your skin will get burnt. That process is actually a reaction, and you could only tell that, my God, this is actually acidic because a reaction occurred. So these chemical properties can only be identified when it has gone through a reaction. So examples of chemical properties are flammability, we have reactivity, we have stability, we have corrosion or corrosivity. Combustion and rusting are also examples of chemical properties. Let's take, for instance, rusting. Rusting simply takes place in the presence of what? Water and what? Air. So iron degrades when it combines with what? Water and air. So we have an equation, let's say 4 molecules of iron, combination with 3 molecules of oxygen and X molecule of water, that's H2, to give us 2 molecules of hydrated iron 3 oxide. Now, what happens there is that there's a reaction that actually happened between iron, water, and air. You figure out that our cutleries at homes hardly get rusted. Why? We ensure that we keep them in safe and dry places where rusting cannot take place. But then the gates in our compounds are actually facing presence of air and water constantly. The rain, and then they're exposed, they're outside, so they easily get rusted. So rust is that brown flaky appearance you see on iron sheets, and it only takes place because there's presence of what? Water and air. Now in the process of this rusting, the pure iron is actually degraded, and then you see an additional substance on it. So a new substance, which is what? Hydrated iron 3 oxide, is formed due to the process of what? Rusting. Having described the two types of properties that matter has, we'll look at the concise difference between the both of them. So a physical property is that property that can be identified without a change in the chemical composition of the substance. On the other hand, a chemical property is that property that can be identified when or after which there has been a change in the chemical composition of the substance. In the process of a physical property, no new substance is formed. You remember when I said a physical property is accompanied by a physical change? Yes, of course. We'll treat the concept of changes of matter in our next class. But as we look at the differences, we'll see that a chemical property can be identified when there's actually a transformation or there's a change in the initial composition of the substance. So a chemical property has or goes through a process where there's a change in the chemical composition of the substance. I believe that in the course of this lecture, you've been able to understand the concept of matter as well as the different states of matter, and then you have a full understanding of the properties, chemical and physical, of matter. This will help us in the further reactions that we'll be treating, how to understand the paths and the ways this reaction occur. There's a box on the screen. You can actually drop your questions and your comments. And then I said we'll be looking at changes of matter in our next class. I hope to see you there.